Today's Leetcode challenge, which is 2116, check if parenthesis string can be valid, right? We're given a parenthesis string. It says a non-empty string consists of like an open bracket and a closed bracket. It's valid if any of the following conditions is true. So basically it says, okay, so it's either true if there's an open and a closed bracket, or like it's A, B, where A and B are parenthesis strings. So basically this next to each other. So this like this and then this again. Or like something like this. Like the main goal is to have, for every open bracket, there's a closed bracket, right? And then it says there's an array of locked, where if locked is 1, that means the index of this cannot be changed. So if this is a closed brace parenthesis, you can't change it to an open one. If it's 0, you can. So you can change this one, you can change this one. Anyone that's 0 corresponds to 0, you can change. So it says just return true if you can make S a valid parenthesis string, otherwise return false. So this is one of the problems where it's marked as medium, but it's definitely hard on the hard side. This is actually the editorial solution. I understood it. But I spent like 3 hours trying to solve this problem, and they kept giving different test cases where it kept making you like redo your thinking. But it's definitely worth like looking at, because the acceptance rate of this problem is really low. It's like 38%. When I see that, I know it's gonna be a hard one. So the main idea here is just for every open parenthesis, you need a closed one, right? And the thing is, you need not only to track that, but you need to track the indexes that you can actually change. Because when you know, let's say you have an open parenthesis, but there's no closed ones, but there's another open one, but you can change it. So that's another case you gotta, you know what, if I explain the solution without actually having to explain the before coding part, it's gonna be easy. So look at this. Obviously, you cannot have odd. If a string is odd, there's no way you can get it valid, because it's not even balanced in the first place, right? We're going to keep track of two stacks. One is called open brackets and one is called unlocked. Open brackets is basically the like these ones, right? And unlocked is the ones we can change, basically. So it's a simple iteration over the length of the string, right? If it's unlocked, sorry, we append it to the unlocked. So unlocked means we can change. So this one is the stack for we can change, right? If it's an open brace, we add it to the open brackets, right? If we encounter a closed brace, now what we do? If we encounter a closed brace and we have in our stack open braces, we can just pop from that, right? But what if we don't? We'll look at unlocked. If we look at unlocked and see, all right, we got one, like there's an entry in unlocked, we can pop it. So that means we balance. We always try to keep the balance. Otherwise, we just return false, because there's no way we can keep going on, right? Now at the end here, we've reached a point where we finished the length of the string, right? We finished the length of the string, but there might still be some unlocked and open brackets, because it's never even. It's never even to begin with, because it's like always going to be like wobbly and stuff. So how do we balance? So we have two stacks. One is called open brackets, one is called unlocked. For each entry in open bracket, we need an unlocked correspondent to be able to return true. Otherwise, it's impossible. So what do? We're going to loop over both arrays and check if the index of open brackets, since we append the index, is less than the index of unlocked. Then for every open bracket, the NAP open bracket has a corresponding unlocked. So we just pop both, right? And then we keep going until it breaks. The moment it breaks, that means we either emptied both or one of them still exists, right? If open brackets still exists, then it's not going to work, because if open bracket still exists and unlocked doesn't exist anymore, we can't balance it, because there's no unlock. But if unlocked still exists, it's good, because that we guaranteed that length is going to be even anyways, because it's never going to be odd. So it's even, so we can iterate it. We can literally change it the way we want, so we can make it valid, right? So we return true. So that's basically the question. right? The time complexity is O of n. It's just hard to come up with a solution because there's a lot of different cases. And I was struggling because I forgot this part, this complete part. I did this part and then I said, and it didn't work. So like, so it made sense to actually look at this. So yeah, thank you guys for watching. See you in the next one.